Hello! Today we'll talk about visibility testing, so we can understand how Unreal Engine handles objects or actors in the world. Why do we care about calling, or let's say hiding objects in the world? Because we have, of course, thousands of actors in the scene, and some or many of them don't need to appear to the player. For example, they are behind the camera or hidden behind other objects or very far away. These objects, if wrongly set up, could still be sent to rendering, and that would waste your GPU resources. So calling simply means don't render what the player cannot actually see. Before talking about calling, we need to know that the camera inside games, or let's say inside Unreal, works with a pyramid view, also called field of view. Everything inside this pyramid should be visible, and everything outside this pyramid should be hidden in the final rendering. All these calling techniques that we will mention are working per object, not per triangles. That means if a little triangle appear in your screen, this entire object will be visible. How does calling work inside Unreal? Distance calling, frustum calling, pre-computed visibility, and occlusion calling. So the distance calling is the simplest one. If an object is farther than a chosen distance, it won't be rendered. But this doesn't apply to Nanite because it has its own system. Frustum calling means only show what's inside the camera's pyramid. Anything outside the frustum will not be sent to rendering, and therefore no draw call is created. Pre-computed visibility. It means stores visibility in some cells, and each time the player will go inside the cell will know exactly what are the other cells to show. Okay, we will talk about that. Occlusion calling means hide objects that are behind other objects. So the order inside Unreal, we start with distance calling. If it's too far, we don't even need to check if it's in the frustum. Then frustum calling, if it's outside the camera, we don't need to check if it's occluded. Pre-computed, use the cells. And finally, occlusion calling, if it's hidden behind something else, don't render this object. But actually, there is a draw call in this case, because occlusion calling is checked by the GPU. We need to have a draw call to tell the GPU to check this information, which is occlusion calling for you. And occlusion calling is the most expensive. We'll start with distance calling. It works fully on the CPU. Remove anything farther than a set distance. You can do this per actor, each object separately, or by using a call volume that affects many models together. This setting is important for performance, but it can cause pop-in, or let's say objects suddenly appear when you get closer. For example, if max distance 7,000 centimeters, then objects at 5,000 centimeters will be visible, but objects beyond 7,000 centimeters will never appear. Of course, as I mentioned, it's not working with Nanite. Now let's talk about frustum calling, also handled by the CPU. At this stage, the object hasn't been sent to a draw call yet. Only objects inside the camera frustum are kept. Objects outside are ignored. So in this example, we have a scene and we have a lot of objects inside and outside the camera. So the frustum will actually not render all these red objects because they are outside. For pre-computed visibility, it also uses CPU, and instead of checking visibility every frame, we can actually save this information in some boxes we call cells. And in these cells, I will save actually what I need to see if our player will go inside the cell. And of course, we don't create pre-computed visibility manually. We just put some volume and alright. For example, for the cell here, I will save information that I will see just cells in this area. Anything behind, for example, this object here will be hidden. So we don't need to check this with occlusion. I will check that before even building the game. So it's an offline information, but it actually works only for static objects or static actors, and also not work for no opaque materials like translucent or masked like grass. Now let's talk about occlusion calling. This one uses the GPU because it depends on the Z buffer. As we mentioned before, there's an information called Z buffer, and it's used to compare if the object is closer or far away from the camera. And of course, we'll know more about that in the GPU and rendering pipelines. All objects that are inside the frustum are sent to the GPU, but the GPU decides which one are hidden behind others. So in this example, we have a lot of objects that are hidden behind others. Are these blue objects are actually hidden by the occlusion calling? But maybe you will ask yourself why this box is still rendered. There is a wall here, and all objects behind this wall are not rendered. We all know that. But for this box here, if part of the object is visible, like through a window, then the wall object will still be rendered. That's why sometimes a box behind a wall still gets rendered, because a small part of it is visible. Now let's talk about something called actor bounds. Here's a question. We actually need to render an object to know if it's visible to our screen. The answer is no. We don't need to render because we have something called bounds, and this information is used to know if actually this actor need to be rendered in the next few frames. Each actor has two bounds, a bounding box and a bounding sphere. Each one is used for a reason. Bounding box fits the object shape used for visibility testing like frustum and occlusion calling. It's used also to know if we need an LOD switching or maybe this object need to cast shadows. And the second bound, which is bounding sphere, and it's used for collision detection. The bounding box is very important because Unreal uses it to predict when the object will appear. This prevent popping an object, which is, for example, suddenly appear without warning, for example. So if a bounds are too big, the object may be rendered too early, and of course this means bad for performance. In any actor settings, actually there is an option for bounce scale, and you can edit this option. But if you increase actors bounds, maybe you will impact your performance. Because if the bounding box, for example, is bigger than your actor, and this bounding box is inside your frustum or pyramid, that means it will be rendered even this object is very far away from the camera, because your frustum will depends on the bounding box, not the object itself. There is a lot of debugging tools that you can actually use. For example, the command freeze rendering. It will stop your current rendering state. You will see a lot of occluded or visible actors in the scene based on your camera view. Stat init views will show some performance stats related to this visibility testing, or let's say this occlusion calling, a lot of informations. Okay, I will show this right now. Also, you can enable the game view by typing G to your keyboard. Okay, let's quickly talk about stat init views. Processed primitives, that means the number of all actors in our scene. And of course, processed primitive include everything in the scene before any calling technique. Frustum called, this is the number of removed actors with frustum calling technique. Statically occluded primitives means we use here pre-computed visibility, and occluded primitives, the number of actors removed by occlusion calling. Visible static mesh elements means any mesh that will be finally rendered, and visible dynamic primitives mean anything movable or dynamic that will be also processed by the GPU. And occlusion queries, how much time the GPU asks this object behind something else, this object also behind something else. So more queries here means more overhead to the GPU. We have three assets here. You can visualize the bounds by typing bounds here in 5.6. There is actually the bounding box and the sphere. If we go to the world and we type freeze rendering, if this object is still visible, that means it will be rendered. But if we enable bounce inside our level, each object we select, we will see his bounce. Now imagine if a little small part of our bound, or let's say bounding box, is visible, that means this entire actor will be rendered. If I hide just the bounding box, we will see that the bounding sphere will also disappear. Why? Because we need to depend on the bounding box, not the sphere. The sphere is used for collision. Imagine now a little small part of this box, which is here, is visible, and we of course disable bounds because it will have a problem. It will have a problem here, and freeze rendering. Yep, this entire object is rendered. Why? Because this small part of bounding box is visible. So you need to make sure that you have the right bounds. Of course, we'll talk about bounds in Culling section. That's it for today. See you in the next lesson.